All right, so we're going to learn a little bit about linear applications, and we're going to throw in domain and range in there also, okay? So here's got some notes for you, fill in the blank notes at the top, and then we're going to do some example problems. All right, so a linear model is a linear equation that represents a word problem. So word problem, okay? Word problem scenario, okay? You can write the equation for a linear model. So the equation for a linear model in the same way you would write the slope-intercept, and we all know what slope-intercept means, right? That means y equals mx plus b. So slope-intercept, okay? And then in parentheses, I'm going to put y equals mx plus b, okay? So the slope-intercept equation of a line, okay? The y-intercept of a linear model is the quantity that you start with, okay, or your starting amount. So the quantity that we'll say you start with, or you begin with, okay, you start with, okay? And in parentheses, I'm going to put this is your b. Okay, this is your b of your equation. Okay, so y equals mx plus b. All right. The slope is the amount or the rate. Okay, so we got the amount slash rate. Okay, remember rate of change is the same thing as slope. The slope is the amount or the rate that changes as it is multiplied by the independent variable. Okay, which is the x. Okay, so this should be independent variable, okay, multiplied by the independent variable or the x value, okay. The change must be at a constant rate, okay, in order for it to be a linear equation, okay. Remember that it needs to be a constant rate of change in order for it to be linear, okay. So that amount or the rate needs to be constant for every single value, okay. All right, so let's go to a couple examples. Example 1, a machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Write an equation that shows the total amount of income the salesman earns if he sells X machines in a year. Okay, so we have a few things going on. Okay, so the base salary, this base salary of $40,000, that is your start. Okay, so this is the starting amount, or in other words, your B. Okay, plus a commission of $300 for every machine he sells. Okay, so the $300 for every, that word there, every or each or per, that indicates your x variable. Okay, so that 300 will be your slope or your m. Okay, so it's write an equation that shows the total amount of income the salesman earns if he sells X machines in a year. So you know X stands for the machines. So what number goes with the machines? Well, that's 300 right here. Okay, so if you write your equation in the form of y equals mx plus b. Okay, and actually let's go ahead and label this 300 as your m. Okay, as your m. All right. So we have our starting amount, the b, and we have our m. Okay, so if we write our equation, we got y is equal to your m, which is 300, x, and then plus your b, which is plus 40,000. And it is both these numbers are positive because we're adding up the total income. Okay. Now, what would be his income if he sold 150 machines? All right. So you just plug in 150 for the machines variable. Which one stands for machines? Well, that is the x. Okay. So you just plug that in for the x. So y is equal to 300 times 150 plus 40,000. Okay, you can do that on the calculator, do it by hand, but I will go ahead and give you the answer to this. The answer should be 85,000. And that'll be $85,000, okay? So if he sells 150 machines for that year, for that period of time, then he's going to make $85,000, okay? Because that's counting his base salary. All right, how many machines would he have to sell in order to earn $55,300, okay? So this 55,300 is the amount he earns, okay? And so we know that the y stands for the total amount of money that he earns. So that's going to be plugged in for the y, okay? So instead of the y equals, we're going to have 55,300 is equal to 300x plus 40,000. Okay? I want you guys to try to practice on solving that for the x. I will give you the answer. The answer should be 51 machines. Okay? But I want you guys to try to solve that by hand and then see if you arrive at 51. Okay? All right, and then what would be a reasonable domain or range if the maximum amount he could earn is 100,000? Okay, so here we go. This is going to take up a little bit of room. All right, so we know the maximum amount he can earn is 100,000, right? So first, we want to figure out how many machines he has to sell to get to $100,000. Okay, so let's go ahead and plug in 100,000. So we got 100,000 is equal to 300x plus 40,000. Okay, and I want you guys to practice solving for x there, but what the number you should arrive at is 200. So x is equal to 200 machines. All right, make sure you practice solving for x there. Okay, so if 200 machines is that means that's the maximum amount of machines he can sell. Okay, because he can't cap out. He has to cap out at $100,000. That's the most he can earn for the year. Okay, so I'm going to separate this paper. All right, so now what we need to do is to find the domain and range. We need to find a minimum for the x and the y. So minimum. All right, and then we want to find a maximum for the x and y. Okay, so the minimum amount. Okay, the minimum amount of machines he can sell. So the minimum for the x variable, the minimum for the x would be 0 machines. Because if he doesn't do anything, he still earns his base salary, $40,000. He probably won't keep his job very long, but that's the minimum he can sell. And so therefore the minimum amount he can earn, so the y, the minimum amount he can earn would be $40,000. Because if you sell 0 machines, you still get that $40,000, okay? All right, so now let's do the maximum. Okay, the maximum is going to come out from over this equation we solved over here to the left. We already know the 100,000 is the maximum amount he can earn, and then we solve for x, and so x is 200 machines, so that's the maximum amount of machines he can sell. Okay, so the maximum amount of machines would be 200. So 200 machines. Okay, and then therefore and it gives us the maximum amount of y. So the y, the maximum amount of machines, maximum amount of dollars he can earn is $100,000. $100,000. Okay, so we have our max and we have our min. Okay, all right. So this domain of range, I don't expect you guys to write it all out because I don't want you to have to write numbers all the way to 200, but it is a discrete graph, a discrete function, because you can't sell 1.5 machines. You either sell 1 machine or 2 machines and so forth, all the way up to 200. So something you can put for your domain of range. So the domain, remember the domain is the x's, okay, so the x's. So the x values, I'm going to put my fancy brackets here, okay. You can sell 0 machines, 1, 2, and then what I'll do is I'll go ... all the way up to 200, okay? So what this is implying is that we're selling from 0 machines all the way to 200, but you cannot include all of those in-between numbers, okay? All right, and so now let's do the range. So the range would be the y's, okay? So I guess we would have to figure out some of these numbers, okay? So we're basically just adding 300 every time. So fancy brackets. The least amount you can earn is 40,000, so that's 40,000, comma, and then if you sell 1 machine, that'll be 40,300, and then we get the point there, and so we're going to go ... all the way over to 100,000, okay? All right. So that tells you your domain and range of this function. Remember, it has to be that discrete domain and range. It cannot be an inequality because it does not involve all the in-between numbers. It only involves those whole numbers for the domain, therefore it has to involve those exact numbers for the range also. Okay? All right, awesome. So here is all of our work that we did there. Okay, so you got your equation, you found for 150 machines, you found for 55,300, then you wanted to find your domain and range. All right, okay. Example number 2. At a school play, tickets cost $7 each. Okay, write an equation that shows the total cost of T tickets. All right, so this one should be fairly simple. So we need to write an equation that shows the total cost of T tickets. So this T here is your independent variable, or your X. And then remember this each here. Each ticket costs $7. So that's going to be your T here. So 7 is connected to your T. So you have a total amount of Y is equal to, and since it's $7 each ticket, that's going to be 7T. Okay. The Y, it could be a Y, it can be an A for total amount. It doesn't matter. Okay. Or it could be C for cost. Actually, let's do C for cost. Yeah, we'll do a capital C for cost. Okay. All right. So now it says, what is the total cost of 4 tickets? Okay. So we have it's asking what is the total cost. So that means we are looking for the C equals, and then it gives us that 4 tickets. Okay. So we're going to have a 7 instead of times T. We're going to multiply that times 4. Okay. And so that should equal $28. Okay. 7 times 4 is 28. Good. All right, then how many tickets? So now it's asking how many tickets. So that's the variable we're trying to solve for. It's trying to solve for the T. And then it gives us the total cost of 56. So 56 gets plugged in for the cost is equal to 7T. And then if you divide by 7 on both sides, then you should get the T, or the number of tickets, is equal to 8. So that's 8 tickets. Okay? So pretty simple. They're just plugging and chugging there. Okay. All right. So now, what is a reasonable domain and range? Okay. If the school sold 200 tickets. All right. So it gives us 200 tickets. Remember, that is the maximum amount of the domain. All right. So you need to take your formula. You need to take the C is equal to 7T, and you need to plug in 200 for your T to find your maximum amount. So C is equal to 7 times 200, because 200 is plugging in for the tickets. So the maximum amount of cost should be 1,400. Okay? All right. So let me separate this. So we need to have a maximum. I'm sorry, let's do minimum first. Minimum and then maximum. Okay. So minimum. Okay. And then we're going to do a maximum. Okay, cool. All right, so the minimum for the X, the number of, T, we're doing T. All right, so let me go back to this right here. This is actually not X, this should be T. Okay, remember our independent variable is T here. So this is T, okay? All right, so the minimum amount for the T is going to be just 0. Okay, so 0 tickets. If no one comes to the play, then they sold 0 tickets. All right, and then the cost, or the C or the Y, the maximum amount is what we just found over here. I'm sorry, the minimum amount would also be $0, because if they don't sell any tickets, they don't make any money. Okay. All right, and then the maximum for the T. The question gave us the maximum for T. That is the 200 tickets in the question. So that is the maximum amount of tickets that they sold. Okay. And then the total cost for those tickets, we found that over to the left, that is $1,400. Okay? And so you need to ask yourself, is this going to be an inequality, meaning does it include all the in-between numbers, or is it going to be a discrete, meaning it only includes the whole numbers? Okay? And you can't sell half a ticket, so therefore you have to have just whole numbers. You can't have those decimals in between. Okay? So the domain is going to be another discrete. So remember, the domain here is all the T values. Okay, so fancy brackets. We're going to start with 0, 1, 2. Okay, so 0, 1, 2. And then I'm going to put a dot, 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 and then all the way to 200. Okay, so that'll represent all of the domain. And then the range, remember that is the C. We have to find a couple of values here. 0, and then if you sell 1 ticket, that'll be 7. If you sell 2 tickets, that'll be 14. and then dot, 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 all the way up to 1400. Okay. So I'm just taking all those domain numbers, I'm multiplying them by 7 to get that range. Okay. All right, so there is your last problem there. All right, I hope this helps.